Welcome to my channel. This video is going to be very interesting and helpful for you because you will find details about risk assessment. As you are receiving a series of videos related to toxicology, so it is more important for you to subscribe this channel to get new videos on time. So, press the bell icon below this video. Also comment and like and share this video with your fellows. After watching this video, you will able to explain what is environmental risk assessment, what is human risk assessment and ecological risk assessment, process of ecological risk assessment, difference between risk and hazard, how hazard can be identified, hazard evaluation or dose response assessment, exposure assessment, risk characterization, risk management, elements to be included in an on-site emergency plan, elements to be included in an off-site emergency plan. Environmental risk assessment is qualitative and quantitative valuation of environmental status. It comprises of human health risk assessment and ecological risk assessment. An environmental risk assessment is a scientific process that identifies and evaluates the likelihood of a chemical to threaten the environment, in particular to living organisms, natural habitats, and ecosystems. Let's discuss what is human health risk assessment. It is a four-step process. It comprises of hazard identification, dose response assessment, exposure assessment, and risk characterization. EPA begins the process of a human health risk assessment with planning and research. The first step, hazard identification, examines whether a stressor has the potential to cause harm to humans and/or ecological systems, and if so, under what circumstances. While dose response assessment examines the numerical relationship between exposure and effects. During step 3, which is exposure assessment, the frequency, timing, and levels of contact with a stressor can be assessed, while risk characterization examines how well the data support conclusions about the nature and extent of the risk from exposure to environmental stressors. A human health risk assessment addresses questions such as, what types of health problems may be caused by environmental stressors such as chemicals and radiation? What is the chance that people will experience health issues when exposed to different levels of environmental stressors? Is there a level below which some chemicals don't pose a human health risk? What environmental stressors are people exposed to and at what levels and for how long? Are some people more likely to be susceptible to environmental stressors because of factors such as age, genetics, pre-existing health conditions, ethnic practices, gender, etc.? Are some people more likely to be exposed to environmental stressors because of factors such as where they work, where they play, what they like to eat, etc.? The answers to these types of questions helps decision makers, whether they are parents or public officials, understand the possible human health risks from environmental media. Do you know the ecological risk assessment determine the likelihood of the occurrence, non-occurrence of adverse ecological effects as a result of exposure to stressors? Ecological risk assessments can be performed to evaluate whether particular environmental conditions like chemical contamination in air, soil, surface water, sediment, or biota, changes in climate, or the introduction of invasive species pose a risk to ecological resources and their associated ecosystem services. Now the question is how ecological risk assessment can be performed? Environmental Protection Agency begins the process of ecological risk assessment with planning and research. It is a three-step process which comprises of problem formulation, analysis and risk characterization. During problem formulation, information is gathered to help determine what, in terms of plants and animals, is at risk and what needs to be protected. Analysis, this is the determination of what plants and animals are exposed and to what degree they are exposed, and if that level of exposure is likely or not to cause harmful ecological effects. While risk characterization includes two major components like risk estimation and risk description. Risk estimation combines exposure profiles and exposure effects. Risk description provides information important for interpreting the risk results and identifies a level for harmful effects on the plants and animals of concern. Now the question is why though risk assessment is necessary? There are a lot of chemical and biological agents are present in the environment that can harm the environment, people inhabiting that environment or their properties. So there's a need to protect environment and people from harmful effects of those chemical and biological agents. An investigation and risk assessment should be done if there is a risk that chemical hazards can cause illness or injury. Come to understand the process of risk assessment. Risk assessment is the process of gathering all available information on the toxic effects of a chemical and evaluating it to determine the possible risks associated with exposure. The process of gathering and evaluating the information can be divided into the following: hazard identification, hazard evaluation, dose-response assessment, exposure assessment, risk characterization, risk management. Before moving to the process of risk assessment, one should know the difference between risk and hazard. A risk is a potential problem. It might occur or might not. Uncertainty: the risk may or may not happen. That is, there are no 100% risks. Those, instead, are called constraints. Loss: the risk becomes a reality and unwanted consequences or losses occur. Risk is defined as the probability that an event will occur. It can also be defined as the probability that a health effect will occur after an individual has been exposed to a specified amount of a hazard. Risk assessment is the process of gathering all available information on the toxic effects of a chemical and evaluating it to determine the possible risks associated with exposure. Let's see what hazard is and what could be the possible hazards around us. A chemical hazard is a substance or a mix of chemicals which can lead to illness or accidents by their hazardous properties, its temperature, and by reducing the concentration of oxygen in the air or increasing risk of fire, explosion, or other dangerous reactions. The chemical hazards should be considered together with the risks of exposure. The assessment shall lead to decisions on what actions to take in order to limit the risks. Now come to learn the process of risk assessment. Its first step is hazard identification. It primarily depends upon two availabilities of data regarding hazards and organization. Hazard identification consists in collecting data from different sources to determine whether a substance is toxic. It involves gathering and examining data from toxicological and epidemiological studies. Epidemiology is the study of the causative factors that are associated with the occurrence and number of cases of disease and illness in a specific population. Information from these studies should answer these questions. Does exposure to the substance produce any adverse effects? If yes, what are the circumstances associated with the exposure? The two major types of epidemiological studies are retrospective and prospective. Retrospective studies attempt to gather information from the past. Sometimes the information is incomplete because of the way the data was gathered. Because of that, it is sometimes difficult to determine if there is a relationship between the effect and a specific factor, such as exposure to a particular toxic substance. Why prospective studies gather information from current, ongoing investigations. For that reason, the results are more complete and accurate than retrospective studies. Both methods are useful in identifying adverse health effects associated with a given toxic substance. Following are the examples of information about hazards: potential release of hazardous chemicals, rate and amount, accidental fires and explosions, transport and fate of pollutants in the environment, dilution dispersion mechanisms and rates, exposure to toxins, who, how many, how much, dose-response predictions based on animal tests, failure rates of mechanical equipment or structures, human behavior, errors by workers, public reaction, natural hazards, earthquake, tsunami, typhoon, alterations in drainage patterns, water table, vegetation, microclimate. Come to know the uncertainties of this process. These include lack of understanding of important cause-effect relationships, lack of scientific theory, models that do not correspond to reality, weaknesses in available data, data gaps, toxicological data that are extrapolated, natural variation in environmental parameters, necessary assumptions on which estimates are based, and the sensitivity of the resulting estimates to changes in the assumptions. Next step of the process of risk assessment is hazard evaluation or dose-response assessment. If the hazard identification process produces evidence of a hazard, then a hazard evaluation is performed. The purpose of this step is to calculate, if possible, the dose at which a harmful effect will occur. Since an effect in animals may not be the same in humans, at the same dose, safety factors are used. Safety factors account for the differences in response of test animals and differences in toxicity. The dose-response assessment tells the toxicologist what dose causes a response, usually illness or death, in the test animal. Next step is exposure assessment. Exposure is an event that occurs when there is contact at a boundary between a human and the environment at a specific contaminant for a specified period of time. An exposure assessment is performed to identify the affected population, if possible, calculate the amount chemical, frequency of exposure, length of time of exposure, route of exposure. Units to express exposure are concentration times time. Factors to consider when performing an exposure assessment include: general information includes identification of molecular formula and structure, how the chemical looks and is made, and other identifying characteristics. It also includes its chemical and physical properties. Source provide information regarding production, distribution, uses, disposal and summary of environmental releases. Exposure pathways and environmental fate. It describes transport and transformation, identification of principal pathways of exposure and prediction of environmental distribution of chemicals. Measured or estimated concentrations provide information related to uses of measurements and estimation of environmental concentrations. Exposed human populations. It includes size and characteristics of population and its location. Integrated exposure analysis. Calculation of exposure includes identification of the exposed population and identification of pathways of exposure. Risk characterization is the final stage of the risk assessment process. This aspect of a risk assessment is comprised of risk estimation and risk description compartments. The overall process is a combining of the ecological effect with the environmental concentration to provide a likelihood of effects given the distribution of the stressor within the system. This process has proven to be difficult to accomplish in a straightforward manner. The probability of toxic impacts is analogous to the weather forecaster's prediction of rain. For instance, when it is said that today there is a 50% chance of rain in the local area, this means that, given the conditions observed, a prediction is made, generally from experience, that the chance of rain is 50 out of 100 trials. Notice that this is not a prediction that it will only rain over half of the forecast area. Similarly, toxicology attempts to make similar predictions regarding the probability of an effect given the conditions of chemical type, concentration, and ecosystem type. This predictive process is still as much an art as weather forecasting. Times risk comparison is done to check the probability of frequency of events causing one or more immediate fatalities. Chance of death for an individual within a specified population in each year. Number of deaths from lifetime exposure. Loss of life expectancy considers the age at which death occurs. Deaths per ton of product or per facility. Risk communication is the process of informing people about potential hazards to their person, property, or community. Scholars define risk communication as a science-based approach for communicating effectively in situations of high stress, high concern, or controversy. Psychologists studying risk perception find that fears are heightened beyond what the objective facts would warrant when risks are involuntary or controlled by others, the consequences are dread and delayed, the benefits and risks are inequitably distributed, the proposed project is unfamiliar and involves complex technology, basic needs such as clean air, drinking water, or food are threatened. This figure shows the connection between risk assessment and risk management through risk characterization. Based on information obtained from the risk assessment, decisions are made about the best way to address environmental contamination and exposure. The risk manager also includes an evaluation of social, legal, economic, and policy issues to determine the best approach to address an exposure issue. Risk management have three important steps: risk analysis and assessment, identification of hazards to people and the environment, the determination of the probability of occurrence of these hazards, and the magnitude of the events. Risk limits entails defining the acceptability of the risk, which can be classified as acceptable or in need of reduction. Risk reduction. Design and implementation of risk-reducing measures and controls. Thanks for watching. Like and share this video. Subscribe this channel to get more informative videos and to become part of a growing scientific community.